Okay, well, for people who are joining this live stream, this is another episode in the process of designing our trees functionality for Wolfram Language. And I'm somewhat optimistic that we are reaching the end of this design process for this area of functionality, which will be exciting. And I gather that a bunch of stuff is implemented in our prototype build. So should I open this notebook in the prototype build, do you think?
Xavier, what do you think? So perhaps we can have a look at the guide page, which is called Trees New. You had a guide page called Trees, so we didn't want to.
I opened it in the prototype build.
Okay. Yeah.
Did we have a trees page before?
It was just the beginning.
Okay. But for this project, right? It wasn't a trees page from the ancient, from like 20 years ago or something.
I think it was for the same one, but
okay.
Here we first wanted to start listing the functionality.
Okay. By the way, a completely random thing that I recently learned, our XML importer, okay, which is a separate binary, apparently is our last straggling 32-bit binary on the Mac. I don't know whether you guys have anything to do with the XML, with the tree generation from XML, or anybody thinks they know anything about that. Nope.
Yeah, I mean, well, it's actually one of two, because there's also QuickTime, but I don't think that's really relevant to this meeting.
Okay, fine. Okay. How do I make a tree here so that I'm, okay.
So perhaps if you go to the ref page of tree element, or Xavier, which one do you think would be better?
Well, we could have a look at both, I think, maybe.
Should I be editing this? Do I need to update before I edit?
I think it may be too soon to go into the details.
Okay, fine. But just for goodness sake, say represents a node in a tree as opposed to just a node, any kind of node, you know. Okay, so there are some random trees. How do I make a just if I want to make, so just if I'm playing around with this, let's say that I say K-array tree using the graph theory functionality, right? I say K-array tree like 30. Okay, so that's going to make a K-array. Now, how do I convert that into this kind of tree? I say graph tree, is that correct?
Yes.
Okay, so that's a little bit unfortunate. Can it not sense the size properly?
Yeah, here it's a default size that I've been using, so this will be updated to have the proper size by default.
By proper size, you mean a size which depends on the content?
Yes, but this is also something that I wanted to discuss. We may have some issue for very, very large tree. For instance, I don't know, if you consider complete carry tree of 10.
Sorry, I'm sorry. Your word dropped out there. If you consider what tree?
If you consider, for instance, complete carry tree of 10, and you do a graph tree on this, we'll have difficulty to represent the tree element object in the end.
I think it would be, I mean, obviously there's a little bit of room for things to resize based on content, but generally speaking, that is weird and unuseful behavior, right? I mean,
I understand. I'm proposing that, I mean, we do it for images where it's really, really good behavior. I think this is a case where we should also do it.
No, because first of all, images have a notion of a natural size, and they don't necessarily display at their natural size either.
Right, but the point is a 4x4 image, for example, does not display as an invisible speck of dust on your screen.
Sure. Right? But, you know, I think our knowledge of this is much less than the knowledge we have of
But I thought we also had a plan, if I'm not mistaken, and Roger maybe can confirm this, for graphs. We are currently not resizing graphs based on content. Is that correct by default?
Right.
But we are planning to do so.
Well, it's
moderately so.
But it's relative, right? The KRE tree there is resized by content.
Wait a second. What do you say? By the way, I'm glad I didn't. I thought you weren't going to be here, Charles. I'm glad you're here. What are you saying, Charles?
I mean, that KRE tree, the size is based on the content, but the current content is based on the plot range of the automatic.
So wait a minute. You're saying if I do a KRE tree of 200, no, I mean the size here, as in the width, is the same in both cases. If I do a KRE tree of 4 or something, that's not very interesting.
Well, but I say we rely currently on the plot range, but yes, we are going, like Roger was pointing out, we are going to find a way to improve that. Right.
So for example, that KRE tree graph would by default look more like this, except that it would have its node sizes better. Is that correct?
Correct.
Okay. So we should do the same, whatever we're going to do there, we might as well do the same up to where we can do it for the trees. Okay, let's
but also, I think for trees, there is a very easy way to, we might not do this in round one, but I think we should consider being able to collapse subtrees, because it's an obvious thing for trees. Trees are so much simpler than graphs.
Yeah, I agree. So you're proposing then that you could click this node and it would collapse.
Right.
I think that would be wonderful. I mean, do we have any comments on that from, I mean, then we'd have to have in tree element, we would have to have an option that says whether it's open or closed.
You also need another box, you know.
You mean another shape of box?
You need to build another front-end box to have that perform reasonably.
Possibly, yes. Does anybody, okay. All right, fine. I think it's a good idea though. Xavier, do you have comments on the tree element design for that?
Yes. So the main point, I suppose, that all of the vertex should keep their coordinates the same when we collapse any of the branches.
Oh, that's an interesting question. Roger, if you collapsed this sub-branch, right, would you expect the 3 to be hanging out there?
Yes.
Same.
And an indicator that there's stuff underneath.
Right, but my point is that this 3 has a lot of extent over from the 1, right? Which it actually doesn't need if everything below it is collapsed.
Yeah, but I think it's too. This is, people complain about this if you needlessly re-render things because you can't visually.
No, I agree with you, but my question. So your point is, I mean, the problem.
I would maintain it stable unless, see, if you plot it from the beginning. You know, in the visualization, you say only visualize up to level 3 or something like that.
Yeah.
And then it's going to have everything collapse. Then it's going to optimize at that point.
Well, and okay, and then you're saying it's going to resize it, relay it out if you open lower levels.
Right. But if you interactively do it, no, I don't think it should disrupt, visually.
Okay, so let me play that. Let's not get down this particular rat hole for too long here, but I can see the issue with that is, let's say there were 1,000 nodes underneath 3, okay? They'll all scrunch together down here unless, in other words, if I keep opening, it's just like thousands of nodes and they're not being given any breathing.
This is why this is probably not a first round project.
Fine.
Okay. Because that will be almost as much work as the rest of it.
Fine. Okay. All right. Let's continue. Okay. Where should we go next? Xavier, Jose, where's the next place to look?
So something that we keep wondering is the relation between tree element and rules tree. So perhaps if you open both pages,
tree element
and rules tree, because as a constructor, tree element is kind of too heavy, and we find ourselves constructing the trees always with rules tree, which is a lot simpler.
Yes.
So to the point that we now wonder which one is a proper container. So constructor rules tree looks kind of more interesting, but as a container. So that's a question Xavier has there at the end.
Okay,
So
so
the-
the question is, what is the canonical form of the tree? Is that basically the question?
Yes.
Yes.
Should the canonical form be, I have to say, my intuition is that having something which has more possibility for metadata and so on is a better idea. That trying to have too thin a canonical form is a mistake. I mean, for graphs, we don't have a very thin canonical form. Is that correct? For a graph, if I look at that graph input form of let's take a look here. Yeah, that's pretty ugly. That's pretty ugly and pretty unusable.
Well, but as an atomic object,
You shouldn't
for
manipulate
efficiency.
expressions. Expressions are not good models for many things.
Yeah,
and also this graph is created from an adjacency matrix. So if it's, you can get an equivalent version if you get a set of holes. So you can have, instead of null sparse array, you can have a set of holes too.
I'm sorry, so how do I get out from that representation? How do I get the thing out as a set of rules?
In principle, it's just edge list is what we provided to user.
Okay, fine. So that's the equivalent then of tree rules. Is that correct?
Yes, we have tree rules and rules tree.
No, I understand. But so tree rules of %2 here is that, which is quite beautiful, but really doesn't contain, doesn't have any place to hang metadata. Right? I mean, that's a useful object there. And presumably if I say tree form of that, I'll get something which is a decorated version of this, right?
Right.
And if I now say for this, if I say rules tree, %9, magnificent apart from the overlapping craziness, right?
Mm-hmm.
So what's wrong with this picture? This seems pretty good to me.
It's not so much the picture, but the fact that when these scales to large graphs, the monolithic representation of a single rules tree or something like that would be more efficient than a nested tree element again and again.
Well,
so,
okay, I can't comment on that. I mean, if you're saying that, I mean, like with graph, that we want some kind of atomic representation, I kind of don't agree with that. I mean, I think, look, if there is some more efficient representation for the nested tree element thing, then there's all kinds of caching possibilities and so on that I can imagine for doing that. But I'm not clear what you're asking. I mean, is the issue an efficiency problem with 1 million tree elements, or is the issue something about the fact that it's inconvenient to work with these nested tree elements?
Xavier, what would you say?
Yeah, I think it's a bit of both. If we have a rules tree representation, we may have some faster manipulation of tree, I think, in the end.
But it's not realistic. It doesn't have a place to hang metadata.
So we can use, so tree element could be used as well as now, actually, to have metadata for any node.
So you're proposing that the canonical form that comes back from something like a graph tree could be some tree element thing. So some of these could be tree elements and some of them could be rules. Is that your proposal?
Yes, and then tree element will be used only to add property to a node. So a bit like,
which is somewhat similar to what we're doing with graph, but
exactly with property. Yes.
No, but the property thing is horrible.
So we could think of something maybe a bit similar with only rules trees. So this would be the canonical representation.
I don't understand why you want to do this. Why? I think it's a mistake for this to be the canonical representation, because I don't think it contains enough information. And I think the idea of mixing this with tree elements seems wrong. I mean, I would just figure out how to make the tree element thing as efficient as possible. And if we really, really, really have to have something where there's an opaque version of some, special fast representation of a tree inside that serializes as tree elements, then so be it.
I see.
But But I'm guessing the problem here, which is kind of similar to graph which have is, I mean, we can, like you suggested, we can put a caching and attach that expression for, if you want to do fast traversal and search, you cannot go to that nested tree element. It'll be inefficient. So probably need a caching.
Right.
More efficient representation we use behind the scene.
Right. That's what I'm saying. Okay, let's continue with this design discussion. I'm not sold on changing. I like the concept. I mean, let me just understand. If I were to look at %2, if I say input form of %2, yeah, I mean, I have no idea what the memory footprint of this is, but that can be dealt with by various forms of caching and so on. But I think conceptually, this is pretty reasonable, isn't it?
Yes, conceptually it's flexible and follows other things like XML element and text element.
I mean, that input form can be, if you have another representation, you call input form, it computes this form.
Yeah.
Might not store that, but it computed, upon request. Serialize it like that.
It also could even happen that could be a post version 1 feature. That's how it works. I think it would be nice to, okay, in any case, I think, I think we could get the trees out as an experimental feature without having some, optimized internal representation. Okay, let's keep going with this review here. Okay. What's this? Somebody's sending some chats thing.
It was just to mention how to change the size the prototype version for the trees.
But I don't want a single size. That's the whole point. I want a size that changes.
Yes. I understand. Yeah, but this was just to mention if you want to change them now, just to make them look nice.
Okay, let's take a look at this. Is that the next thing to look at?
Yes, this is typesetting.
So what is
proposals? So the first line are the proposals from Chris.
Is Chris here?
No, not here.
Okay, so please get him if we're going to talk about this thing. Okay, let's loop back to something else. Okay.
So this is the discussion we were just having, and we could look at other pages.
Yes, please. And I want to. So, have you implemented all of the things that were for tree traversal? And did we finish the design of all the tree traversal, tree extraction, uncle's grandfather's piece of a tree type stuff?
I think so. From the point of view of design, we have this tree path, which is quite flexible because it's both a part specification and a structure specification. And
okay, so can I see that? So let's see. So you have a tree path page here?
Not tree path yet, but tree extract, for example.
Tree extract, yes.
Okay, so let me take my tree here. Let's take TTT is %2. That's my tree. So now let me kind of look at. So if I say tree extract of, let me see if I can guess how to do this. Can I say element 5? And can I say, is that going to be the subtree?
Well, 5.
Well, here, the element named 5. How do I extract the subtree of the element named 5?
Well, many elements could be named 5. So this is.
How do I extract all of their subtrees?
So this is extraction by position, like tree extract. That's
okay, but
like extract does.
Is it by position or by name? So if I say this,
this is position. It has to be a position that exists.
Is the left-hand side the 1?
Yes, so this is 1, 2, but this is in a tree path wrapper. So this is tree path 1, 2.
What does 1, 2 mean?
And without the list?
Without the tree path. I'm totally confused here. This is, why is this not 1, 2?
So yes, this is 1, 2, but this is without the list actually.
Yes. So remove the
Oh, I
list.
see.
This is like a part spec. So lists are for
just like parts
threading.
of multi-part things.
Exactly.
So I could say 1, 2.
1, comma.
Because there's a binary tree, I would say 1, 2 down there.
Yeah.
And that would make me 2 subtrees.
Exactly.
Okay.
Exactly.
So now, if I get down there and then I say uncles.
So
those trees don't have any uncles.
So it should be specified within the tree path.
Right.
What's the third argument? Oh, those elements from the association. Okay, so if I say here...
Is to get the data, the metadata of the nodes, the third argument.
Okay, let me see if I understand what on earth that did. Okay, so 1, 2, 1, 1, 2.
No.
Yes.
So,
the first part of the tree path is the 1 element, the 2 element. So it lands on the 5, right? Mm-hmm. Then I go to that element and that element. Okay. So that, yeah, that's right. That's the parent and that's the uncle.
Mm-hmm.
Right?
Yeah.
So they both have the same uncle.
Right.
Okay.
So the idea is that the second element of tree extract can also take a list, which is a list of tree paths. And then each tree path can specify lists, which means sub-lists.
Okay, but how would I extract by name?
Well, that's a tree cases.
Tree cases, yes.
Okay. Do we have tree cases?
No, we don't. Yes, the main thing was to first check how to implement a tree pattern, because it may be a bit difficult or non-friendly to specify a subtree that we want to extract.
Well, you're saying a tree pattern that isn't just a single node pattern, right?
Yes.
In other words, if what we want, is a subtree based on name.
Yes. Well, so the difficulty here is that if we could have a tree cases and use directly tree element as pattern, but since it's going to evaluate, we will have to wrap this with whole pattern. With
why? What's going to evaluate?
So the tree element, the expression tree element that we want to use for tree cases.
Yeah, why is that going to evaluate? Isn't tree element an inert object?
So it's going to be passed to a canonical form.
Yeah, so what?
So for instance, if you do tree element bracket, let's say 1, comma blank bracket.
Oh, sorry, you're saying, okay. Let's first of all, let's look at what you've got here. Okay. So first thing is, let me just understand. So let's say this one here. So let's say flatten %21. Two identical things, but let's say, and now I say tree expression, just for fun. Okay, that seems wrong. It should be listable there.
Okay, yeah, we'll add that, yes.
Okay. Wild but correct. So then if I say expression tree, that works. Okay. Okay, so what other things? So these are conversion construction things.
Yeah.
Somebody is asking on the live stream, will this be integrated with other tree-related things such as text structure and dendrogram? What does dendrogram actually return? Dendrogram returns a graphic.
Right, because dendrogram is means the graphical thing.
But what's the thing underneath dendrogram? It's a clustering tree, right? And the clustering tree, so let's take a look at what that does, because that's the underlying of this. So let's say random. Okay, so there's our clustering tree. Now, what the heck is that? Is that a graph?
Yes.
Okay, so if I say graph tree, very nice, except that we lost the labels. We lost the leaf labels.
Yes, so there is an option in graph tree to keep them. It's tree lemma. Yes.
Why isn't that the default? So %26, okay, so what do I do to keep those?
So in a string, this is tree element labels.
Like this?
Yes. Goes to...
What are we doing with an option in a string? Go on, but tell me what it should be here.
Goes to automatic. No, so this is... Oh, yes, this is because they're using... I see. Okay, so this is a bug. So here we keep them, but I need to fix this bug misplaced.
This looks kind of horrifying. So I think there are 2 points here. So clustering tree arguably should return a tree.
I'm not sure about that.
Why wouldn't it?
Well, it's a big change.
Well, okay, we can worry about that. I mean, but conceptually it should return a tree. Maybe, maybe not. What is it doing here? I don't understand that. What did it do here? Is that badly rendered on top of each other or something, or what? That is badly rendered. Could somebody comment on that? Who's PMing here?
Sushma.
Okay. Could you deal with that? That's obviously really awful documentation example. I mean, there are actually 2 problems here. One is these things should be resized down to thumbnail size when they're put in here. And second of all, okay, but then the question of whether this is a tree or whether it is a graph that has to be converted to a tree is a separate question. But the other thing is when we do have a graph, we do have a graph. The question of how we move over graph annotation. I mean, presumably, if I have a graph that isn't a tree and I say graph tree, it'll just say, forget it. You've got something that isn't. I mean, if I say complete graph of 4 or something like this. Okay, and now I say graph tree. It just says, forget it. Oh, come on. That's our general principle for error is not to say should be anything. It's just is not. And this is a very awkward way to say it. Is not a tree. Just say it's not a tree. And don't say argument 1. Just say blah, blah, blah is not a tree. Reasonable, Xavier?
Okay, I will change it, yes.
But that's a general principle of our messages. Is simply say what we know. Don't say what it ought to be, so to speak. Okay. From our live stream, we have a comment that guessing that the issue is that dendrogram has much more going on, e.g. branch weights, than a conventional abstract tree. That's an interesting point. I don't know how the weights are represented here. Does somebody know? And in fact, is it the case? I mean, that's the whole point of our tree element structure, is that we can put weights into the tree element structure, correct?
Yes, we can add any type of data.
Right, which is why it's really nice to have that, you know, metadata capable symbolic expression. So, comment from Michael Hale here says he's writing a Wolfram community post on visualizing the amount of GenBank sequence data available for related species subtrees right now. Great, I'd be interested to see it. I'm kind of hoping that I would hope that some of our clustering tree functionality would be relevant for that. But yes, this is okay. Another question here: is there an implementation of suffix trees? What would that mean exactly? I mean, we have a thing that's actually getting much. Okay, here's a question for you guys. So we have autocomplete, right? And let's imagine that we have, you know, random word. Let's say we have 30 random words here. Okay, and now we say autocomplete with that. That makes an autocompletion function. And if we say autocompletion function of B, let's say, I think this will make, there we go, that. Now, I think this is making a suffix tree. No, that is conceptually internally a suffix tree, is it not? Roger, Charles, somebody?
I don't know how this is implemented.
Well, I know how this is implemented.
It should be, but
yeah, I mean, conceptually.
I mean, we use suffix tree for all kinds of things, but I'm not. I don't know who wrote it.
An implicit question here is: should we be exposing a suffix tree? What would a suffix tree look like in our tree formalism? And then, how would you use a suffix tree if it was represented in our tree formalism? Do you get what I'm saying?
That might be a cool application example to think about, you know.
Yeah, right. But let's think about how that would work. I mean, in other words, okay, let's do as an exercise. Let's create a suffix tree, okay? How would we do that? So we want to go from here, right?
Yes.
Tell me how to create the suffix tree. Maybe I can make a more trivial suffix tree with just tuples or something. Is that reasonable?
I guess we will have to separate characters and then doing some sort of nested gather by. But the exact combination.
All right, let's take this as an example. Right, this should be easier to make a suffix tree out of. Right, so what's going to happen then is what's going to happen here? It's going to be gathering from the first element and then mapping the gather. How does this work? Gather by first or something, is that right? Hey, we've got background noise. Could somebody make sure they're muted? Is that right? But we're not then saying what the gather element. Look, this seems like a good exercise to make a suffix tree. And then the question is, once we have that suffix tree, how would we use it?
Try group by first arrow rest.
That looks lovely. Okay, and then you're going to tell me to go.
Now I guess we have to do fold.
Why are we folding?
Nest.
Why aren't we just mapping?
Oh, okay. We can map at the next level the same thing.
Oh, that's not right, because we really have to go and well, okay, here, let's just get 2 levels of the suffix tree, okay?
Yeah.
So for this, we'd go map group by hash first arrow rest. Okay, all right, now let me turn this into a tree. How do I turn this into a tree? Actually, I'm just gonna, just for fun, I'm gonna go 1 more level, okay? So I want to do this, correct?
Yes.
Okay, all right. Now, how do I turn that into a tree? Let me actually.
We need values of it. No, we need the rules. We need normal.
Okay, maybe we shouldn't need normal, but yeah, okay. But we need a nested normal, right?
Yes.
It's kind of funky.
I see. So probably we needed to wrap normal around the group bys.
Well, I mean, we could just map all normal here.
Okay.
Not that it hurts anything.
Yeah.
Okay.
Okay.
So now this is a rules tree, right? So now what I want to say is rules tree of that. Yes?
Yes. So we have a list at the end, which is, let's see what happens. Yeah.
That is not encouraging. Why is that list at the end causing trouble? I don't think it should do.
It's being written.
But let's just, for the sake of having something work, let's put an F around that list at the end, okay? So it's level -2, -3.
So I think one issue is that we don't have a root here.
Oh, yes, yeah.
Okay, explain that. So how would we make, I see, so there's 2 elements at the top level, right?
Yes.
So what should we do in that case with a rules tree with 2 elements at the top level?
Or maybe you can just add, I don't know.
Well, no, what should we do? I think this should make 2 disjoint tree pieces. Do Roger and Charles have an opinion about that? Roger?
Sorry, I was on mute. Say it again.
Yes. So we were wondering whether rules tree of a list should do a single tree or several trees.
Well, I can't do a single tree because they're not connected to a root.
Yeah, but we could introduce some sort of fictitious root, like we do. Null goes to that list.
Well, if you have 2 roots, right? I mean, do they constitute 2 disconnected trees or not? If they are disconnected trees, should be 2 different trees.
Yeah, but we don't know. I mean, this is a case, we're trying to build a suffix tree here, and the suffix tree has no, I mean, this would be, I don't know, if it was the other way around, this would be an epsilon or something. In the world of transducers or something, that would be some sort of, Roger, what would this be in the world of transducers? How would you start this thing?
Yes, you could have an epsilon transition into both, yes. But I don't know if this is the only, what's the most useful behavior for it to have? Is it most useful to have 1 tree or multiple trees?
Well, let's try with 2 trees, okay? So in this case, what I could do here, I could say map rules tree over this, right?
Yes, and can you replace the F by flatten?
Why?
Just to have something cleaner in the previous input.
Okay, fair enough. But I just want to see what this does. Okay, fine. So it's a little bit, yeah, okay, I get it.
But could you try again the rules tree of bracket %45? I think it should work actually. So now it should already have it should thread on the first argument. So, okay, so this is a bug, yeah.
Okay, but so
I think it should make a forest. I'm not joking, quite seriously, because in all the serious pre-application, the mathematical ones, not the ones that are just for display, like for Barger trees, differential equations, integration of manifolds, one always wants to keep who is together nicely.
So you mean trees should represent forests, or do you mean a list of trees?
No, I meant we should have a simple forest.
Okay.
Which is a technical term.
Yes.
Okay, so this raises the question, which we haven't even touched on, of machine learning, decision trees and things. Has anybody looked at whether these map onto the stuff that we have for decision trees in the machine learning system?
We haven't.
And or random forests, so we should look at that. Etienne would know about that. Okay, but let's take this example for a this is trying to be a suffix tree. How will we use the suffix tree? So we would presumably use a tree extract. The suffix tree is presumably a tree extract of, let's just do the first one here. So notice that we've got a mess on our hands because the tree extract, we would like there to be a root here. If we're going to use tree extract on the thing, if there was a root, now we got to do this tree path, which I'm not sure I totally like anymore. And again, we can't do tree path by name. We're doing tree path by, this is a mess, guys. We're doing tree path by position, whereas we really want for the suffix tree to do tree path by name. So that seems to be a thing that's coming up a fair bit.
It depends.
The tree by name. Go ahead.
I think we need both things, like we need extract and cases in general.
Yeah, but this isn't quite tree cases because this is walk the tree, but at every node, decide which side you're going based on the name of the node, not on the part number of the node.
Yes. So we agree we need both, and actually tree path should even be able to do cases as it goes down.
Okay, well, how? I mean, yes, that's what I think too. I think it should be able to go either by position, either by part number, or by name. Possibly or by other metadata, I'm not sure. But I don't see how to specify that.
So here it's working with cases, with a cases operator. So tree path bracket, cases, brackets, and the pattern for 3 elements.
What? What are you saying? So if I want this to go down, go ahead.
You can do tree path brackets, cases, brackets. So here this gets complicated because we don't have a tree pattern. So this will be whole pattern instead of one.
What? This is going to get way too complicated.
Yeah, so then this is 3 elements and so on, yeah.
Right, we lost this game. So, but what we need to do here is assume that the names are unique, right? Which they might not be, and there are different cases if they're not. But assume they've been correctly, the tree has been set up as a uniquely named tree. Possibly something that there should be a Q function that tests for. What would the mathematical name for a tree with unique names be?
That's not really a mathematical concept, right? I mean, that's like uniquely labeled Q or something.
Yeah, right. Well, okay, but so in that case, this is almost like a tree name path, right? That looks at the names rather than the, it's almost like there's a tree part path and a tree name path. Am I making sense?
I'm not sure. Our plan was to have some sort of query ability at each level. So each time that you go one level deeper or upper in tree path, we wanted to put here a form of query that would take cases in a particular case. Just that we have focused on the positional aspects so far.
Right. I think we're going to want a name thing. I think it's going to be useful for many purposes. Just a simple thing where you can say, extract the, walk down the tree, extracting such and such an element. For example, the suffix tree case is an example of that. By the way, I also think we probably actually need a function to make a suffix tree, which is what is internally happening. In this case, it's also internally happening in genome lookup and a bunch of other things. Am I making sense? In other words, there's no reason we can't have something that creates a suffix tree from a list of objects, a list of lists. Does that make sense?
I think we can have many constructors, and that would be one.
Right.
So I'm saying that's what making it rich. If you have a.
No, I agree. But okay, so we agree we're going to have a suffix tree constructor. Okay, somebody is asking on the live stream about a tree option that represents family trees as in genetic memetic. I don't know what memetic means, but what does it mean? where a single individual has two parents or more. Yes, yes, yes. How do we deal with that? How do we even think about that?
We don't in this construction. Here
but if we were to generalize our trees, so for example, in the Wolfram Alpha world, if I say, if I say uncle's grandmother, I'm getting that.
Mm-hmm.
What is this from a tree point of view? Is it a tree or is it not? I mean, that's a fragment of a tree, right? There's an infinite tree, so to speak, or a tree with 100 billion nodes for all the humans who've ever lived, right? And you get, I mean, with the human case, you get like these hourglass diagrams, right? Where there's you in the middle and there's, how do those trees relate? Is the hourglass diagram?
Well, it's not a tree.
It's not a tree. I mean, it would be directed acyclic graph, but which is the.
Yes, our concept is this ordered, oriented, rooted trees, and this is, if we take the nodes to be the couples or individuals, then this will be like two of those trees, one oriented upwards and then the other one downwards.
Well, that's the case where you're in the middle,
right?
Where you have descendants and you have ancestors.
Right.
But I think there are like 3 or 4 different standard views of a genealogical tree, which, as you point out, is not really a tree.
There are several concepts, and we are using a restricted concept, this ordered, oriented, rooted tree.
Fair enough. Okay, another person is suggesting collapsible tree. They're showing an example here of a collapsible tree. Yeah, well, right. This is what we're talking about with I don't know how this is working, but yeah. Now notice that this one does move as the thing we were talking about before, whether the thing moves as you open a node.
But notice how they have the sort of incremental animations going on there too, to help visually, so you don't get this,
The yeah, I mean, that kind of mechanism is certainly a type of tree visualization that we would like to have, and that's, I mean, that goes along the lines of what we were discussing earlier with these trees with openers. All right, let's go back here to let's see, what else do we need to achieve in this meeting? Have we been making? I mean, I would like to go through some other actual use cases here, but go ahead, Javier. What else do you want to make sure we achieve here?
Sorry to interrupt, but I'm just warning you, I have a meeting with external people in 3 minutes, so I'll have to drop out in the next minute.
Okay.
Yes, so Chris joined, so maybe we can go back to the typesetting.
Okay. Okay. So what is this now? Why are we using these nasty brown?
This is me from the copy pasting, I think. It's much clearer on the web.
No, but I mean, I understand, but that color is our old graph plot color, which I don't think worked out that well.
I think I must have pulled that color incorrectly from a prior version of the documentation. And looking at what we've been looking at on the screen today, I will bring it back to our current blue-gray style.
Okay, but so what is this? What is this a picture of? What are you illustrating here?
This was as I was trying to tackle this, besides just a little bit of the actual visual styling, I was looking at what we do with. I'm sorry, I've lost the original file here. Trees nested within a tree. If you have, say, in your root node here, We can have children off that, but in the sample notebook that I have, we have, you can have sort of elements nested within this parent element. So I was initially playing around without really taking into a lot of consideration the technical constraints of, can we have an opener or an ellipses to show
right, so that's not where we're at right now. So
okay.
that's cool for the future, but that's not where we're at right now. What problem are we trying to solve? What thing do we think is not working in this visualization here, which looks quite reasonable to me?
Now that I look at it again, and now that I'm doing another review of the documentation, visually, I think it's pretty much in line with the new styles that we are using.
I don't think so. I mean, I don't know whether we like yellow as the color, as the theming color for these things, but it doesn't seem obviously wrong.
Mm-hmm.
Okay, so does anybody, so if I were to have a node here that has no label, how would that display right now? Can I see one of those, Javier? Is there an easy way to make a tree without a label there?
Let's see. Maybe rules tree A goes to B, C.
Like this?
And comma, I think this should be vertex labels goes to, and here I think I'm using a null for this prototype. I'm not sure. No, so it all, no, I don't think we can do it in an easy way then. Oh, it's null, sorry.
Okay. So in general here, what's that?
Yeah, I might be able to actually find the sample code that I was going from to base this off of.
But what did we have? So if I do a rules tree of %9 with vertex labels to none, would I get similar behavior here?
Yeah, they should remove the.
Okay, looks quite beautiful. Okay, anybody have a problem with this? It looks okay to me. I mean, I'm not totally certain about the shade of yellow and things, but it looks, I mean, the geometry looks pretty good to me. Roger, Charles, Michael, anybody?
Well, I don't think we should go with yellow.
What would be your favorite color?
I don't know, but yellow feels very, very, 2-3 versions ago.
It'd be a bit boring, but we could simply go with a very light gray in the background or pure white, but that's not particularly.
No, pure white won't be good.
Yeah, it needs a little something.
What places could we imagine taking the palette for this from?
And the other thing, it probably needs a theme, doesn't it? Plot theme, so you can.
Yeah, it probably does.
There's a few standard things, and then you can have something that's more sort of energetic, visually active, and something that's just more everyday.
Right, but the question is, what should the everyday one be? What would be the where could we draw the palette for this from? I mean, in graph, what do the nodes look like in graph? They're bluish, aren't they?
I think so.
Yeah.
Yeah.
But now, if I label a node here, so if I say, can I do this? Vertex labels are automatic.
Yeah.
Okay. So we're labeling the nodes for a graph. We're labeling external to the node. How can I put those labels inside the nodes?
Placed center.
How do I do it?
You replace automatic by place in quote name, comma center.
Oh, name?
Yes.
Oh.
You have to specify the actual label. What's the label username?
Okay, well, that's pretty ugly.
Yeah, not enough contrast.
So, I mean, that would be the natural palette to use here.
Mm-hmm.
Do we want, and again, for the edges, don't we want the edges for the tree to agree with the edges for the graph by default, guys?
I think it's important that you something that visually indicates it's not a graph, because otherwise you kind of. And I think that the more of these things we do, the more we need to come up with some more, a little bit, since they're close but not the same, visual cues that tells you what kind of thing that you can expect to do with it. So here you see the area around it, the frame around it has a different color when it's a graph.
No, they're both purple.
Well, but that means it's a graph.
Yes, because in this case, we are using a graph.
No, I understand, but you're saying it's purple as opposed to orange for in the case of an ordinary graphic.
Right.
Yeah, I like that. I mean,
as well as the mouse over, which have a different shape.
What's the mouse over shape here?
I mean, the mouse appearance.
You see the mouse has an edge on it?
Yeah.
Well, both graphs.
Well, I know they're both graphs. So if I just do a graphics circle or something, you're saying the mouse has an arrow in that case or something.
Yeah.
I never noticed. I did notice that it was different. I couldn't figure out what that thing was. What is that? That's a little edge. That's the icon for I'm a graph.
Right.
Yeah.
It's on an edge.
What's that?
Yes, it's on edge. Yes.
Okay, but your point is.
But I think that there's been fairly muted at this point. But if we're going to have more objects that are visually very close to each other but not the same, I think we're going to have to become a little bit more in your face. That you know.
Are you sure? I mean, there are plenty of expressions that aren't the same, but it's not quite correct. I mean, there certainly are indications that we give in different places of things being different, which I think have worked out fairly well. But in this case, what does Michael think? Do you have an idea? Michael has disappeared. Okay, well, so I don't think we've solved this problem of what the visual look should be. I think what Javier has right now is certainly not terrible. I think, the palette has to somehow agree or disagree with graphs. I think it's super unfortunate what happens when the labels are placed as they are there with a graph. If I say vertex style arrow something or other, can I get that to yeah, I mean, it's still kind of ugly because I don't have the things large enough. How would I specify them large enough?
Vertex size goes to medium.
How did that?
Oh, sorry. Put an explicit number. That's maybe 10, 5. Oh.
What on earth are the units here? That's quite beautiful. That's beautiful. Be nice if that was easier to do. I mean, arguably,
it wasn't label centric. I think that we can do, going forward. There are various visual tricks, like using scrims is an important aspect. Actually placing them in a more adaptive fashion.
Okay, I've got a very simple suggestion. Just like you have a named, vertex labels arrow automatic, vertex labels arrow name. Let's have a string name that produces vertex labels inside the vertices.
Okay. I mean, they're often big, they won't fit.
I understand. So then it won't work. But if they do fit, then give people a way to easily ask for them. Yeah. So, I mean, it would be something like, name in place. That's not the right terminology. But you get what I'm saying. That's some annotation to the word name.
Mm-hmm.
Because this is very nice, what it did here. Very nice. Okay. All right. Does Javier need anything else right now? And by the way, I don't think we need to kill these meetings while Jose is away.
Yeah, that's fine. Yeah, of course.
I mean, it's great for Jose to be here, but I don't think it's absolutely essential. And I'd like to continue them so that we can actually, hit our targets with this for version 12. Okay. And anything else for this meeting? Thanks to folks on the live stream. Number of very useful comments today. Thank you. And thanks to everybody in the meeting. And have a good trip, Jose.
Thank you.
See you later, guys.
Bye.
Bye.